Everyone. Today we will be starting with Boolean Algebra, which is also a part of first unit of class 11th Computer Science, and this is the most easiest unit in all of CS, and it's very fun to learn this. So let's begin. First of all, we should know what is the definition of Boolean algebra. So Boolean logic basically deals with variables that have only two values. See, computer, as we have studied, is a binary, has only two inputs, and it has the language of binary, and binary consists of 0 and 1. So in Boolean algebra, 0 stands for false and 1 stands for true. So that is the main logic of Boolean algebra. We have two values, 0 and 1, which stands for false and true respectively. And this is the foundation of digital electronics and computer system. And every device in every electronic gadget that we are using, we are basically using Boolean algebra in this. And next we will see the gates in Boolean algebra. That is the foundation of Boolean algebra. So the basic Boolean gates are 3 in Boolean algebra. But before that, we will see the definition of a gate. A gate is a basic electronic circuit which operates on one or more signals to produce an output signal. See, we are giving input to a device, which is basically an electronic device, and we are getting an output from that device. So that is basically a gate. Now, in Boolean algebra, we are studying 3 main gates. First is NOT gate, second is AND gate, third is OR gate. And the hint to remember all these gates is now, NAO. Not and or. Now we will see each and every gate in detail. So the first one is NOT gate, which is also called an inverter gate. So the function, the main logic for this gate is that it reverses the input. As the name suggests, it is a NOT gate, so we are getting the inverted output for that. Now the expression for this is y is equals to naught of a. See, the naught of a can also be represented by putting a bar on top of a, or we can put a comma on a. That represents the naught for the symbol, and y is here the output. Now if we talk about the diagram for this, we have basically a triangle shaped gate symbol for this, and in front of that there's a small circle. So we are giving one input and we are getting one output from this. So this is the NOT gate, and the truth table for this is if the input is a and the output is y, so when the value of a is 0, the output is 1, and when the value of a is 1, the output is 0. So this is NOT gate, which is called inverter gate. Next we will move to the second gate, that is the AND gate. So the AND gate functions only when both the inputs are 1. We are getting the output 1 only when both the inputs are 1. And the expression for this is y is equals to a dot b. Here dot stands for multiplication. We are basically multiplying both the inputs to get the desired output. Now the symbol for AND gate looks like D. As the word AND has D in it, so does the logic symbol for this also has the shape of D in this. Here 2 inputs are given and the output is a single output. Now the truth table for this is C, A and B. We will write, to draw this truth table, we will write, first we will write 2 zeros and 2 ones, then 0 1 0 1. Now multiply these two. 0 into 0 is 0, 0 into 1 is also 0, 1 into 0 is 0, and 1 into 1 is 1. So the idea is we are getting the output as 1 only when both the inputs are 1, otherwise there is no output, or we can say the output is 0. Next we have OR gate. See, this functions when at least one input is 1. If both the inputs are 0, then we are getting the output as 0, otherwise we will get the output as 1. So the expression for this is y is equals to a plus b. That means we are adding both the inputs and getting the output for our. So the symbol for OR gate is this, and here also we have 2 inputs and we are getting a single output from this. So this is OR gate. And the truth table for this is, see, in the first row we are getting 0 and all the other outputs are 1. So basically whenever there is 1 present in the truth table, the output is 1, otherwise the output is 0. Now we will study some universal gates. See, universal gates are those gates which help in forming the other Boolean gates. In our syllabus, we have NAND and NOR gate as the basic universal gates. So let's study the NAND gate first. As the name suggests, it is the inverse of AND gate. So basically AND gate is y is equals to a into b, and if we put a bar on top of it, we are getting the NAND gate. And the symbol for this is same as the AND gate, and from inverter gate we are putting a small circle in front of it, and that becomes our NAND gate. So the truth table for this is, see, when the output was 1 in AND gate, we were getting, when the input was 1 in AND gate, we were getting the output as 1. And in all the other cases, it was 0. So it will be reverse of this in NAND gate. When the output is 1, the inputs are basically 0. And when the input is 1, in both the cases, the output is 0, as shown in this truth table. The second universal gate is NOR gate, and the expression for this is a plus b complement. See, it is doing the reverse of NOR gate, and the symbol for this is also the same. First we are drawing the OR gate, and in front of that we are putting a small circle, and that becomes our NOR gate. Now to see the truth table for this, we are getting output as 1 when both the inputs are 0, and in all the other cases the output is 0. So this becomes our NOR gate, and these two are universal gates. That means they help in performing or forming all the other gates of Boolean algebra. Now we have another gate, that is XOR gate, which is also called exclusive OR gate. Now here output is 1 if inputs are different. See, if we are having the same input combination, then there will be output 0. Otherwise, in all the cases, the output will be 1. So its expression is written as A XOR B, and this symbol drawn in the middle represents for XOR gate. The symbol for this is like OR gate, and in front of it we are putting another line. So this is the symbol for XOR gate. And the truth table for this, you can see that in the first row, when both the inputs are same, that is it is 0, then we are getting the output as 0. And in the second row, when one input is 0 and the other one is 1, the output is 1. And in the third row again, when one input is 1 and the other is 0, we are getting the output as 1. And when both the inputs are same in the last row, then we are getting the output as 0. So XOR gate is basically giving us output 1 when both the inputs are different. Next, we have some Boolean algebra laws. As in mathematics, we have various laws and identities to study this. Here also in Boolean algebra, we have certain laws which we can use to simplify the expressions, and these questions are asked in the paper and also in other competitive exams. So let's begin. The first law is properties of 0 and 1. This is the most simple law. If we add 0 in any number, in any Boolean algebra number, that is 0 or 1, we are getting the output as the same number. So we have summarized it as 0 plus x is equals to x. Similarly, if we add 1 in any variable, then also we are getting the output as 1. And if we multiply any number by 0, the output is 0. And 1 plus x is 1. So this is the property of 0 and 1. Second law is idempotent law. It states that x plus x is equals to x. See, if we are doing 0 plus 0, it's giving output as 0. 0 plus, both the values of x should be same. That's why it is giving the output as x. And the next is any number multiplied by itself also gives the same number. See, 0 into 0 is 0. So that law also falls. Similarly, 1 into 1 is 1. So that law also falls, behaves. So this is idempotent law. Next law is involution. This is also called double inversion law. See, if we are complementing a number and then again we are complementing that number, we get the original number back. So that's why it is written as x complement. The symbol drawn over x represents for complement. So x complements complement gives the same value of x. So this is the involution law. Next we have complementary law. Here x plus x complement is 1. See, 0 plus x complement is 1. So 0 plus 1 is 1. So this law also follows. Next is x into x complement gives 0. A simple way to learn this is that in place of plus, write dot, and in place of 1, write 0. Then if you learn one law, you will be able to formulate the other law. So this is the complementary law. Next we have commutative law. This is the same one as we have studied in mathematics. X plus y is equals to y plus x. You can add numbers in any order, you will get the same output. And x into y is equals to y into x. You do either 0 into 1 or 1 into 0, the output will be the same, that is 0. So this is the commutative law. Next we have associative law. In association, we can add any two numbers first and then the other two first. So if we are given three inputs x, y, z, we can either add y and z together or we can add x and y together. So this is associative law. And as I said, replace plus with multiply. So x into y into z. If we multiply y and z together, we get the same output as multiplied by x and y together. Next we have distributive law. In distributive law, we have this distributive property as in mathematics. So x bracket y plus z is basically x multiplied by y plus x multiplied by z. We are basically solving the brackets. And as we replace the multiply symbol with plus, here also x plus y and x plus z is equals to x plus y into z. So this is the distributive law. Next we have absorption law. Under this, x plus xy is equals to x. So this law is a little bit different, but you can remember this as if any other number is added, multiplied with x and the terms are added, then we get the output as x only. And we can also write it as x into x plus y is equals to x. Now the last law is De Morgan's theorem. This is the most important theorem in Boolean algebra. If you don't remember any of the laws, you must remember the De Morgan's law. So under De Morgan's law, we have two basically theorems. First law is not of and. Here x dot y whole complement is equals to x complement plus y complement. See, the main motive of De Morgan's is to convert the and symbol into or and put a bar on each variable. So when we are breaking it down, x into y, we are doing this as x plus y, and this whole bar is broken down into smaller bars, and we can also represent this through diagram. So this is AND gate and x and y are given input, and then we are doing the complement of this, we get x into y complement. And it can also be represented as doing the complement of individual components and then adding them. So this gives the diagram for the first theorem. Now the second law is that not of or. Here we are doing the or operation, that is x plus y, then doing the not of this, and it gives the output as x complement into y complement. Here also first we are doing or. This gives output x plus y, and this is the NOT gate. So this is giving x plus y complement. Or we can represent it as doing the individual complement of each element, and then we are doing AND operation on that. So we are getting x complement into y complement. Here I have given the remember trick for this. Convert AND, which is represented by dot, into OR, which is represented by plus, and then put not bar on each variable. We have to break the bar and change the sign. So this is the De Morgan's law, very, very important in this. Now to summarize all the laws. First is properties of 0 and 1. Any number added in 0 gives the same number. Any number added 1 gives 1 as output. Any number multiplied by 1 gives the same number. Any number multiplied by 0 gives the output as 0. Idempotence law. When the same number is added, we get the same number. When the same number is multiplied, we get the same number. Next is involution law, double negation. Complement of a complement gives the same number. Complementary law is x plus x complement is 1 and x into x complement is 0. Commutative law, same in mathematics. X plus y is equals to y plus x and x into y is equal to y into x. Order of things does not change things. Next is associative law. Here we are adding any two numbers together and then the third number, we are getting the same output. Similarly, in multiplication also, numbers multiplied in any order gives the same number. Next is distributive law. Here we are solving the brackets. So xy plus xz is equals to xy plus z. Next is absorption law. Here x plus xy gives x and x into x plus y also gives x. And the last one, De Morgan's law. x into y complement gives x complement plus y complement, and x plus y whole complement gives x complement into y complement. So these all are the laws for Boolean algebra. That's it for today. I hope you like this video. Thank you.